let's start. Okay. So welcome guys, welcome to NEET World. So in this session we are going to see the physics of motion in a straight line. Okay. So in last class we have seen some questions regarding the topic. Okay. So the last topic we have started with the motion in a straight line, no, and we have discussed with the displacement, distance, velocity, acceleration, instantaneous velocity, instantaneous acceleration, and we have seen some questions, right? Now, so this was the last question. So we'll go for the next question. So the next question is, a car runs at constant speed on a circular track of a radius 10 centimeter. I'll take a pen. Okay. Yeah. So circle, no, which is having a radius of 10 meter. Okay, 10 meter. Now what they are saying, track of a 10 meter taking 6.28 seconds on each lap. Each lap in the sense completing each lap. Complete one circle. Okay, one complete circle. Okay. The average speed and average velocity they are asking. So what is the formula for speed? Average speed, total distance by total time. Fine. What about the average velocity? This is average speed, no? So V average I will take, and V bar average, that is velocity. Okay. I have mentioned with some arrow mark. So which is equals to total displacement. Okay, displacement by time. Total time, no? Total time. Now if I see, let me consider this point as A, and I am completing one complete circle. Again I am coming to point A, which means distance will be equals to 2 pi r, whereas displacement will be equals to 0. Final position is same, initial position also same, right now. So when final initial position are same, displacement will be 0. Okay. So what about 2 pi r? 2 into 3.14 into r is 10, right? So when I do the calculation for this one, no, okay, which is equals to 2 into 3.14 is 6.28. Okay, 6.28 into 10, it is 62.8. we will get 62.8, right? No, 62.8. So for average velocity it is 0. Average velocity is 0, but I need to find what is average speed. So distance is 62.8 and time is 6.28 seconds. 6.28 seconds. Okay. So when I do this calculation, no, I will get the answer as 10. Okay, 10. So when I multiply by 10 by 10, no, here I will get 62.8. This 62.8 and this one will get cancelled, so remaining 10 will be there. So average speed will be 10, but whereas average velocity will be 0. So velocity 0 is there, speed should be 10. So option 2 is the answer. Okay. Done. Okay, we'll go for the next question. Done now? A particle moves in east direction with 15 meter per second for 2 seconds, then northward with 5 meter per second for 8 seconds. Average speed of a particle is. So, first we will write what are the given terms here. Okay. So, the given terms are like particle moves east direction. So, this is my east direction, which is nothing but 15 meter per second for 2 seconds, and northward, this is my north, no. So, 5 meter per second for 8 seconds. I need to find the average speed. So, what is the average speed formula? Average speed is equals to total distance by total time. But here they have mentioned it as speed, no, like speed they have mentioned and time they have mentioned. So, I can find the distance of eastward and distance of northward. So, when I calculate distance of east, so speed equals to distance by time, whereas distance will be equals to speed into time. Okay, speed is 15 and time is given 2 seconds, which is nothing but 30, no, 15 to 30. So, distance similarly for distance of north, okay, northward. So, eastward we got, then northward. So, D is equals to S into T, where 5 into 8 is 40. So, 40 meter, this is 30 meter. Now, we know that in eastward the time is taken is 2 seconds, in northward the time is taken is 8 seconds, and the distance is calculated 30 and 40. So, the total distance is 30 plus 40, 70. Total time is 2 plus 8 is 10. So, which is nothing but 7 meter per second is the average speed, option 3. Done. So, the next question is, particle moves x distance in time t according to the equation x is equals to t plus power, so t plus 5 power minus 1. The acceleration of the particle is proportional to. Here the option is given like velocity power 2 by 3, velocity power 3 by 2, distance square and distance power minus 2. So, distance in the sense the same thing, this is the distance, no. If I directly substitute the value, I should get the acceleration. So, first we will find what is the acceleration equation. So, what I should do? Displacement, velocity, acceleration, I need to differentiate it. So, from displacement to velocity, first differentiation, velocity to acceleration, again differentiation. So, directly from displacement to acceleration, two differentiation I need to do. So x will be equals to t plus 5 power minus 1, right? No, t plus 5 power minus 1. If I differentiate this one, no, v will be equals to, so what is the differentiation formula? X equals to, I mean x power n will be equals to n into x power n minus 1 is the formula, right? So what is n here? Minus 1. So minus 1 into x is t plus 5 power minus 1 minus 1. Okay, again what is the differentiation of this term t plus 5? Only 1 I will get. Okay, 1. Okay, so what is the answer here? Minus 1 t plus 5 power minus 2. This is for velocity, equation for velocity. Now for the acceleration, a will be equals to, again minus 1 into minus 2 power t plus, I mean into t plus 5 power minus 2 minus 1. So which is nothing but 2 into t plus 5 power minus 3. Okay, this is my acceleration equation. Now what is the thing is, either I can substitute the values here or I can cross check the answers. Okay, if I take this equation and substitute in this first option, no, I should get the value. Okay, I should get the value of the acceleration. What they told? Velocity power 2 by 3. So what is the equation of velocity? Minus 1 into t plus 5 power minus 2. I should take this equation and substitute in the option 1. Again option 2, what they are saying? Velocity power 3 by 2. Same velocity equation only I should take. Okay, velocity equation, take it and keep in option 2 and see whether I am getting the acceleration. So I need to get this answer. To get this answer, I am using this x and the value of v. Okay, and in distance what they are told? Distance square, no. So distance they have given directly equation. X is equals to t plus 5 power minus 1. So if I square this one, I will get this one, 2 into t plus 5 power minus 3. Power 2 is the maximum thing. Here power 3 is there. I won't get it. So I can easily eliminate the option 3 and option 4. Right? No. Square only is there. No. Power 2. Here the maximum power is 3. Right? No. So either it should be velocity, I mean option 1 or option 2. But when I see the option 1, no, option 1, it is velocity power 2 by 3. 2 by 3. Here it is power 2. When simply you can take 2 power 2 by 3, what will happen? I will get 4 by 3, right? No, 4 by 3. But what I get for velocity power 3 by 2? So 2 power 3 by 2, this 2 and 2 will get cancelled, I will get 3. So obviously I can say the answer is option 2. Yes, no? By elimination method, by using this I can eliminate this one. Yes, no? And these two only the thing. So from these two I need to check whether which is the correct option. Okay? Okay, we will go for the next question. The position vector of a particle changes with time according to the relation. So there is a position vector equation. What is the magnitude of acceleration at t is equals to 1? So magnitude of acceleration. First the position is given. If I differentiate, I will get the velocity. Again if I differentiate, I will get the acceleration. So first we will do the differentiation and we will see what is the thing we are getting. Okay. So r of t is equals to 15 t square I cap plus 4 minus 20 t square j cap. So differentiate with respect to t. So velocity I will get as 30 t I cap plus minus 40 t j cap. Okay. So acceleration I will get 30 minus 40. So 30 I cap minus 40 j cap. Okay. Now what they are asking, at time t is equals to 1, no, is there any constant of t here? No. So no need to do anything with t. And they are asking magnitude, no. So magnitude means what I should do? I should take modulus, no. So 30 square plus minus 40 square, which is nothing but this is 900 plus 1600, which is nothing but root over 2500. Option is 50. So 50 meter per second square is the answer, option 4. Done. So whenever they are asking magnitude, so I cap j cap will be given or k cap also is there. Take the magnitude, means under root of I cap square, j cap square, k cap square. Okay. You can take. Done? Yeah. So the next question is, if a body is moving with a constant speed, then its acceleration. So we have talked about the constant speed. Constant speed in the sense zero acceleration. Right now there is no acceleration. So option 1 will be the answer, must be 0. Right now. So constant speed, zero acceleration, that's it. Okay. So the next topic what we are going to see is, so till now we have discussed about the velocity, acceleration and distance, displacement, everything. Now the thing is kinematic equations. Okay. So in kinematic equation we have seen 3 main equation, no? So what are the 3 main equation? V is equals to u plus at, v square minus u square is equals to 2as, and s is equals to ut plus of at square, where v is the final velocity, u is the initial velocity, okay, and a is the acceleration, t is the time, and s is the displacement. Okay, you can take a note of this. So there is one more equation. So if they are asking what is the displacement of a particle in t seconds or nth second, okay, nth second in the sense like a particle is moving constantly with some velocity or anything, okay, at time t is equals to 8 seconds, what is the displacement? Okay, so formula will be Sn will be equals to u plus a by 2 into 2n minus 1. So this is for displacement in nth second. Okay, take down. So, this is the main thing in the kinematic equations. Okay. Remember the 3 equation and the 4th equation. The 4 equations are important. Okay. So, whenever the acceleration is constant, okay, acceleration constant in the sense we can use this 3 equation plus this 4th equation. So, acceleration is variable, we can't use the kinematic equation, that is the thing we should remember. Okay. So, the next thing is we will see the questions, I mean the important points we will see, and then we will see the questions of this topic. Okay. So, the next note point, okay, distance covered in equal time interval. Okay, equal time interval in the sense for a distance 100 meter is there, for example. Okay. So, for first 10 seconds 100 meter, next 10 seconds again 100 meter, again next 10 seconds again 100 meter, for example we are considering. Okay. So, distance covered in equal interval of time. Okay. So, how I can say, like first 10 seconds 100 meter, next 10 seconds which is 20 seconds, no, 10 seconds the total distance is 200 meter, again next 10 seconds is 300 meter, like totally we have covered right now. So, if an object starts from rest, which is initial velocity will be 0 and moves with a uniform acceleration, the total distance covered after t is proportional to t square. Okay. Keep in mind, whenever they are saying distance covered in equal time interval, S will be directly proportional to t square. Okay, t square. I will write here. So, for example, after 1 second distance is 1 square, after 2 seconds distance is 2 square, after 3 seconds 3 square. Okay. So, total distance after 1, 2, 3 seconds are in ratio of 1:4:9 again 16, right? No, square of the numbers will get 1, 4, 9, 16, 25, 36, like that. Okay. Yeah. So, distance S is directly proportional to t square. Okay. Done. We will go for the next note point. So, this is note point number 1. Okay. So, the next note point is completed. Yeah. Distance covered in each separate seconds. So, here each separate second in the sense, here we look at the distance only in the nth second, not total from the start. Okay. So, initially what we have seen, for 10 seconds 100 meter, 20 seconds 200 meter, 30 seconds 300 meter, but here in this case for 10 seconds how much, again for the next 10 seconds how much, separately we need to find it. Okay. It means nth second. Okay, nth second. So, formula is distance is directly proportional to 2n minus 1, there it is t square. Okay. Ut plus of 80 square, of 80 square is the formula, no, I will write the formula here. So, S is equals to ut plus of at square, then Sn is equals to u plus 1 by 2 means a by 2, no, into 2n minus 1, right. So, what they told initially at rest, initially at rest in the sense this one can be neglected out. So, acceleration is constant, no need to take out the acceleration. So, S is directly proportional to t square for t seconds. Here what they told like nth seconds, no, in the previous case the total. Okay, so it is 2n minus 1. Okay, so here the ratios will be, for 1 it is 2 into 1 minus 1, which is nothing but 1. For 2 seconds, 2 into 2 minus 1, which is 4 minus 1, 3. Again 5. Okay, the odd numbers will come 1, 3, 5, 7, 9, like that. Okay, now so 2 into 4, 8 minus 1, 7. 2 into 5, 10 minus 1, 9. 2 into 6 minus 1, 11. Okay, like that the distance will be covered. Okay, you can take it. Done. Yes. Completed, no? You go for the next. The next note pointers. So braking distance. If a body is moving with the speed u and brake are applied, it stops after covering a distance s. So if you are going with some speed, suddenly brake applied. So how much distance you have traveled, we will calculate, no? So for that, now the same body moves with a speed nu, says double or triple the speed. Okay, you are going with 10 meter per second, 10 meter per second, and you have applied brake, you are calculating the distance. In the second time, what you are doing is 20 meter per second, which is more than initial speed, that is twice the initial speed, no? Yes or no? So how much distance you have covered? Again 30 meter per second, how much distance you have covered? So here, and the same brakes are applied, the stopping distance become the proportional to nu power 2. Okay, nu power 2. So stopping distance is n square into s. Okay, n square into s. So take a note point as a stopping distance become proportional to nu power 2, whole power 2. Okay. So if a speed is double, stopping distance become 4 times. If speed is triple, it becomes 9 times. Again 4 times means 16 times, no? So for example, you are going with 10 meter per second and distance travelled is 20 meter. Again you are going with 20 meter per second. How much distance is? 4 times, no, 4 times in the sense 80 will be the answer, na? Yes or no? 80 will be the answer. You are going with 30 meter per second. What happens? 9 times. So 20 into 9 is how much? 180. So 180 meter you are traveling. Okay, that's it. That's the way we are applying this concept. Done. So now we will see the questions. Some questions in this topics. Can we see now? So first question is, initially a body is at rest. So body is at rest in the sense, so listen one thing, whenever you are solving questions, read the questions and write whatever given in the questions. Okay. So first what they have given, initially body at rest, u is equals to 0. If it's accelerate at 5 meter per second square, no, 5 meter per second square, then distance travelled in the 18th second, right? No, 18th second. So S 18th. So what is the formula I should use? Nth formula, right? No, Sn is equals to u plus a by 2 into 2n minus 1, where n is equals to 18. Okay, substitute the values here. U is 0, 0 plus what is a? 5, 5 by 2 into 18 minus 1, right? No, that's it. So what I will get? 5 by 2 into what is 18 minus 1? 17. 17 2s are 2n, no, 2n minus 1. So 2n minus 1, 2 times n minus 1. Okay, 18 2s are 36, minus 1 is 35. Okay, so 35 I will get. Okay, so what I should do? Multiply, no? So what I will get? So I will cancel this one and cancel this one. 2.5. So 2.5 into 35. 35 2s are 70, but of 35 is 17.5. So 70 plus 17.5 is 87.5 is I will get, no? 2 times I am multiplying. Again half of 35 I should take, right? No? So what will get? 70 plus 17.5, which is nothing but 87.5. So this is my answer, option B, right? Done, no? The next question. Okay. If a car at rest accelerate uniformly to a speed of 144 km per hour in 20 seconds, it covers a distance of. So what are the given terms first? Rest, no? It is at rest, which is nothing but u will be equals to 0. Accelerates, no, accelerate uniformly to a speed of 144. So v will be equals to 144 km per hour for 20 seconds. T is equals to 20. Okay, it covers a distance of. Okay, distance I need to find. So what is the thing? How to find now? First we need to convert to meter per second. Fine, good. So 144 into 5 by 18, no? 1 times, and this is 2 times, huh?
8 times.
8, and this will be 40 meter per second. Okay. Next, time is given, v we know, u we know. Then
40 to 20.
S is equals to ut plus of at square. Here a is not there. Okay. V square minus u square equals to 2as. Here also a is there. Then v is equals to u plus at. Here I can find the value of a, no? In the third equation I can find the value of a and substitute either in first and second equation. I will get the value of s. I need the distance covered, no? That's it. So what is the final velocity? 40, right? No. So 40 minus 0 divided by how much time? 20 seconds, no? So 20 is equals to A, where 0 0 will get cancelled. A will be equals to 2 meter per second square. Done. 2 meter per second square. So take the value of A, either substitute in 1 or 2. So what is 1? S is equals to ut plus of at square. So where it is 0, no, I can neglect it out. So 1 by 2 into how much? 20 seconds, no, 20 whole square. Done. So 2 and 2 will get cancelled. 20 square is 400. So option 2. Done. So by using the kinematic equation, any of this equation I can find the value of A and then substitute the values A in the equation. That's it. What is A? Final velocity minus initial velocity by time. That's it, no? Change in velocity by time taken is acceleration. Can we see 2 more questions now? Then completed calculations. Can we see? Done, no? This one? Okay. The displacement of a body is given. So what is the displacement is given? S is equals to of gt square. So where g is the acceleration due to gravity, the velocity of a body at any time. So if displacement is given, what I should do? Differentiate, I will get the velocity, right? No. So S is equals to 1 by 2 gt square. If I differentiate this one, what I will get? Velocity will be equals to 1 by 2 g into 2t, where 2 and 2 will get cancelled. Option will be gt. Option 3. That's it. So displacement is given, I need velocity at any time. Any time in the sense time is there, okay, at any time I am differentiating, that's it, I will get the velocity. Suppose they are given velocity and they are asking what is the displacement, what I should do? Integration, okay, integration I need to do, that's it, fine. So the next question is, a body starts at rest. Listen carefully, we have seen the note points, no? Listen carefully. A body starts at rest, start from rest, and uniformly accelerated for 30 seconds. Distance travelled in first 10 seconds, next 10 seconds, next 10 seconds. So x1, x2, x3 is the same as. How to find now? Option will be 3, no? Yes, no? So 1:3, 3:5, that's it. So 2 note points we have seen. One is for t seconds, that is nth second, no? Right, no? This is a thing we have seen, no? Yeah. So if an object starts from rest and moves with uniform acceleration, next thing is, here we look at the distance only in nth second, that's it. So options are 1:3, 3:5. So that is uniform acceleration is there, okay. So keep in mind 1:3, 3:5, and one more thing is 1:4, 9:16, 25, it's going, okay. So with this we will end this session and we will go for the next topic in the next session, okay.